Hey guys, today we are going to talk about dividing polynomials using long division. So, the first thing that you want to do when you're dividing any type of polynomial is you want to check and see if you can divide using factoring. Factoring is an easier method, it's a little more efficient. So the first thing you want to do is check and see. So I'm going to look at this polynomial to see, can I actually factor it? So again, with factoring, your first step is always to look for a greatest common factor. There's no GCF, so here it's a trinomial. So I'm looking at this is medium trinomial factoring. So I would use my expanding and grouping method. 2 times 20 is 40, so I'm asking myself, are there any factors of 40 that subtract to give me 11? If I listed all my factors, I would realize there is not, which means I cannot factor. Okay, so that's going to lead me to using long division. So I'm going to rewrite my polynomial using my long division bar, something that you first used or first learned about probably in about 4th grade. Okay, I'm checking to make sure that this polynomial is written in standard form from the highest degree down to the constant, which it is, and I'm also checking to see if there are any missing terms. Any missing terms. So I have my 2nd degree term, this is my 1st degree term, and then I have my constant. So I'm not missing anything. If there were, I would make sure to rewrite this polynomial including all my terms. Okay, but I'm not missing anything, so I can just rewrite it the way it is. And I am going to divide by this binomial. Okay, so one thing that I like to do is either highlight or kind of underline the first term in this binomial. This is the term that I'm going to be using when I'm actually doing my division. Okay, so the first thing you want to ask is how many times does 2x go into the first term we have here, 2x squared. So off to the side, I can rewrite this as 2x squared divided by 2x. Okay, I'm going to use my exponent rules here. I'm going to divide my coefficients, they cancel out, and x squared divided by x to the first is x. Again, I'm using the exponent properties, which tells me to keep my base and subtract my exponents. So this is really x to the first power, which means when I go to rewrite it, I'm looking for my other term inside the divisor that is x to the first. That would be here. So I'm going to write my x right above that. And as you probably remember from doing long division when you were younger, now you need to take whatever term you have up here and multiply it by whatever term you're dividing by. So again, I'm going to do this off to the side. So that means I'm doing x times 2x minus 3. That gives me 2x squared minus 3x. So I'm going to write that underneath my polynomial here. So now, as you remember from doing long division when you were young, okay, you now need to subtract. Okay, so notice I'm putting parentheses around this polynomial. So I'm going to be subtracting 2x squared minus 2x squared. That is going to cancel out. Now that is something that should happen each time. Okay, your first term should always cancel. So now I have negative 11x minus a negative 3x. Okay, so since I have double negatives, I know that's really the same thing as negative 11x plus 3x, which is negative 8x. Okay, so that's going to go underneath. And again, just like when you were young and you were doing long division, we want to bring down any number, any term that's over here. So now I'm going to repeat this process. Okay, now I'm again looking at the first term here, and I want to know how many times 2x divides into negative 8x. Okay, divide my coefficients first. That gives me negative 4. My x's cancel out. So I'm going to write that above, and notice this is a constant term, which is over a constant term. And now I'm going to take this negative 4 and multiply again. So negative 4 times 2x minus 3 is negative 8x plus 12. Let me write this underneath. And again, now I'm going to subtract. I'm making sure to add in parentheses. So I do okay with my signs. Negative 8 minus a negative 8. So again, negative 8 minus a negative is really plus. So negative 8 plus 8 cancels out, which is what we need there. So we know we're doing this okay. And negative 20 minus 12 is negative 32. Okay, so as you remember, because we have a number here and there's nothing else to bring down, this means that this number is our remainder. Okay, so whenever we have a remainder, and I keep the sign, my remainder always is going to go over, I'm going to rewrite it as a fraction, over the number that I'm dividing by. So my final answer to this problem, when I divide these two polynomials, is x minus 4 minus 32 over 2x minus 3. And again, having a remainder makes sense here. The reason why we had to use polynomial long division is because we get a remainder. Okay, if you're able to do division where you don't have a remainder, that means you could have factored. And you would just take your answer or check your answer by multiplying these two terms together. But again, this makes sense because we checked it, we couldn't factor. So this is our final answer.